easier to maintain. It also means that because it's lightweight, it doesn't have to carry around as much batteries, which makes it even more lighter weight. And then the idea of basically not having to need as many software pushes or updates if, you know, the cloud software is upgraded, suddenly every robot connected to it just got an upgrade for free. And if, you know, the data center hardware is upgraded, the hard disks and the CPU and the network speeds are all upgraded, every robot just got a free upgrade. And then the final point is this idea of having a central repository of apps or skills. So you can think about an app store for a robot, where if you develop a unique skill that you teach your robot to do something, it'd be really great if you could upload that skill, have other people download it and use it, and then have a way that the robots can grow in functionality as the community builds interesting and clever, novel ways of using those robots. And so I think there's a lot of interesting potential here, and that's sort of why I've been advocating for this within Google and outside of Google. So I'll just give you a couple examples that Google has already taken that some of you may be familiar with and some of you may not be. How many people have heard of Google Goggles? Some of you. Good. It's kind of interesting. The idea is that you can take your mobile phone, you can download this app for free, and you can snap a picture of, let's say, this painting, and it will actually upload the image to Google's cloud, and within a few seconds it will actually return back to you the name of the artist and the name of the painting that it discovered, and it knows because it's been crawling and indexing the web, and it knows that it's seen this painting many times and has been able to deduce that from the knowledge that the Google servers have been caching. And so it's kind of interesting that, well, wouldn't that be useful for a robot? So a robot could be able to just look at something and know the name of the artist who painted that painting. So then we have this idea of robot goggles. So what if you know, a robot encounters an object that the user has asked it to pick up, and it actually has never picked up that object before, and it actually wants to know, well, is there anything I can get information about that object so that I can have a better chance of succeeding at this task? And so it could take a picture of the object, upload it to the cloud, and then get back actually some very useful metadata. It could say, okay, this is a cup, it's made of plastic, this is the friction components of the material, here's how you should grasp it, don't tip it. So there could be lots of different useful semantic information and domain knowledge that could then be downloaded and transmitted to the robot. Another example that you know, is existing and many of you are using now is speech and translation. So Google has you know, over 50 and now 84 languages now in our corpus for Google Translate, and we've been using basically data mining and statistical machine translation to build better and better ways of communicating. And my inspiration here is C-3PO. I'm a big Star Wars fan. I guess I should be a big Disney fan now. But the idea is that C-3PO was able to speak you know, thousands of different languages, or 6 million forms of communication, I believe it was. But the idea would be that your robot should be able to actually just listen to any language and be able to translate it, or read signs written in a different language. I think that would be something really, really useful. And finally, mapping and planning. You know, Google has invested many years and a lot of technology into building the world's best maps. We think we have the world's best maps. And wouldn't it be great if all the robots could access them and use them to do navigation and find out where they are if they're lost? And one of the great things about having this shared is that, for example, a robot navigating someplace could then, you know, if it found that actually there's an accident in this street and there's a block, it could actually publish that to the database, and that would be immediately known and perceived by anybody else who's trying to navigate the same place. And so this shared knowledge base and knowledge transfer that's happening interactive in real time globally, I think is a very exciting concept. So when I joined Google, I actually spent about a year and a half working on their self-driving Lexus, and definitely having good maps was one of the things that we wanted to have for our robot cars. And also thank you, Toyota, for the very nice Lexus. So we are also building these, you know, this technology as a prototype, but also we hope that it will impact the society, lead to a safer society. And so this idea of having shared data for both cars as well as robot devices and household robots, I think is something that would be a great vision to help improve the society. So just to summarize, I think we are seeing robots that are gradually moving out of factories, entering our lives. I think the vision that Dr. Oda presented of having partner robots that can assist both in domestic as well as office environments outside of factories is very compelling. I think cloud robotics, and I hope you could agree with me that it enables cheaper, lighter, and smarter robots by making it more cost-effective and possible to implement with existing technology and leveraging the existing infrastructure we have in a way that can drive the innovation. I think the infrastructure already exists, and how we take advantage of it is up to us. And by creating this shared knowledge base, I believe that it can enable a robot revolution by having experiences and user interactions and learned skills shared among all of these cloud-connected robots. Finally, I don't know how many people have used Google Now before if you have an Android phone, but I just wanted to show you, and just in case you haven't seen it before, I can say something to my phone. Who is the Prime Minister of Japan? And it just, gave me a picture of Yoshiko Noda, and it tells me, where he is. I can also say something like, how tall is Tokyo Tower? Somebody knows really, really well. Yeah. It looks like it's trying to connect to the Wi-Fi here, so I should turn off my Wi-Fi so it just goes over my cell net. But anyway, the point is that you have already starting to build out a voice-based interface for communicating with the knowledge that's stored in the cloud, and I think that's a great start for getting that kind of interface for real robots. Thank you very much.
So I think I want to start out by asking each of you what you think is the biggest challenge for robots to go into the homes, for the audience to be able to have robots in their homes. Oh, yes, please start.
So the one thing I can think about is that as I have been involved in this ISO standardization committee for last year, since 2006, so it's about the last 6 years or so, I see that a lot of industry, or this robotics industry, is now facing a very challenging problem. That so especially in Japan, as nobody mentioned in our slides, that a lot of Japanese industry researchers are working on these service robots, humanoid type robots. But since there's no international standard on service robots, and a lot of industry needs to comply standards, ISO and IEC standards, to have safe and good quality products. But there's no standard, international standard yet, or an international national standard yet on robotics. So a lot of industry is waiting for this first publication. And I said that I have been involved in this activity. I can say that we are responsible. This first publication of the robotics personal care robot standards will be out about a year from now. But the next summer we are targeting to have this first year publication next summer. Then a lot of companies, robotics industry, can follow and comply with this standard. So once we did, also a lot of companies in worldwide can comply and follow this, how to design, what are the design requirements and so on, then we can get into more fast production and also commercializations. So that's one of the challenges, I think.
So, are these standards mainly for the safety of the robots? Can you talk a little more about what these standards are?
Yes, so a lot of ISO and IEC standards, as you may know, are based on the safety standards. So nowadays, a lot of for my ISO standardization activity, a lot of industry and also the standardization organizations are working on robotic safety, how mechanical components have to be designed, and how electrical components such as sensors and also the laser scanners and also the cameras have to be designed. Also, including e-stops have to be designed with complying the IEC other standards and so on.
That's really interesting that you talk about standards, because I think Brian has a little different idea about standards, perhaps. So can you talk a little about your idea with standards and also what you think is the biggest challenge right now?
Sure. So, I mean, there are different kinds of standards, right? I think the kinds of standards that Dr. Oda is referring to are very important. Those are, safety and quality and performance standards. Standards can mean something different to people in a software context. They might be standards for a software interface that's blessed by an international body to ensure interoperability of software components. And that's where there have actually been many efforts over the years to put together software standards for robots. And I've been involved in enough of them to not want to go back and be involved in more of them. So I think we'll get there eventually, but I think it's still too soon on the software standard side. That's a different kind of standard. I think that, I guess I should say that the biggest hurdle to getting robots into people's homes is having the right building blocks, because that's what we do. But I think actually a bigger hurdle is setting expectations in the minds of users. So I think people are very used to using special purpose machines that do one job very well. You have appliances in your house that wash your clothes, that dry your clothes, that wash your dishes, all those sorts of things, and that's a very well understood kind of interaction with a machine. What we're talking about here is a more general purpose machine, like the partner support robot is clearly going to do more than one specific task, and that's great, but that also opens you up for a lot of potential disappointment on the part of the user. If the user is going to see that this robot can drive around, it has an arm, it has a hand, why can't it pick up everything, right? Why can't it autonomously pick up my wine glass? Well, it's because the wine glass is transparent. The robot can't see that, but people aren't going to think about that. And I think the speech interfaces are fantastic. Also an opportunity for disappointment when it doesn't work. So that's I think I mean, we absolutely have to push on the technology and get it out there, but I think there's a real potential to not do well in the market if you don't have the right expectations set for the people who are using robots.
Yeah, I think I agree with a lot of what has been said before, and I think for me, having worked in almost 20 years and trying to get humanoid robots deployed, I think the main barrier has always been the cost. How can we build reliability and cost? And I think the efforts for actually building these open source tools are really fantastic, because it allows well-tested, reliable community of interested users to find bugs and fix them, and start to converge towards reliable base software that then you can build on top of. And then driving down the cost, I talked a little bit about some of the advantages I think for cloud robotics, but I think the open source development is very key. And then also the society acceptance. So building these consumer safety standards and things are very important, but also we have to be willing as a society to accept the risks of a new technology as long as they're reasonable. Some people have said that if engineers are the engine of society, lawyers are the friction. It's been a big challenge. I worked for a long time, trying to make Google's self-driving car more reliable. I actually was the engineer responsible for the planning software, and there was a lot of question as to whether or not there would be a legal framework that we could ever sell a self-driving car. And I'm happy to say that now Florida, California, and Nevada have all provided the framework for a deployment of a regulated, safe, quality assurance. You can get a license for your robot self-driving car. That's the vision. I think we, as a society, when people had proposed self-flying airplanes, the autopilot, right? Well, people were suspicious. They said, oh well, at least there's a human pilot there to take over when the going gets tough. What a lot of people don't realize is that that's actually when the autopilot is engaged, when there's zero visibility, and the human pilot is very much prone to error. So, but now we take it for granted that we can fly safely with the assistance of a machine helping to pilot the aircraft. I think the same is true for cars. And so we have to sort of, as a society, be willing to accept that there will be a risk with every new technology, but what is the net positive, and how will it drive innovation and make things better? So the same thing with robots in our home. We say, let's make sure that there's safety standards, but let's also not stagnate innovation just because we're afraid of lawyers.
So I think setting expectations is really, really important. I think what all of you just said are the baseline is to how to set expectations. So there will be safety standards, but not everything is, there's always going to be danger. It may fall on you, anything can happen. This watch may be dangerous for me, someone can throw it to me and I can hurt my head. So what do we do how do we set the expectations with robots?
So from Toyota's view, that we are trying to commercialize our products by the next couple of years, starting from Japan, and we are following that when the aging population and the workforce shortage, we're trying to get more healthcare applications, and that's what I see in other Japanese corporations like Panasonic and Honda are trying to get also Cyberdyne. They have this wearable suit of the Cyberdyne, and basically Japanese corporations and industry. So healthcare and medical applications. So for expectations, that it's a hard question, and it's just my personal opinion, but so that I assume that from my previous response that once we get this some sort of ISO and OIC standardizations issued in the next 1 year or so, a lot of companies can follow, not only Japan and US, but many other companies also. And I know that in Germany, Germany is very big and active in robotics research. So I assume that from Japan, Germany, or other other countries in European countries, and also US, is also active on this military, also aerospace, and also including PR2. A lot of companies, also mostly researchers, are trying to use your PR2 applications. So I assume that will get much more development and also production coming out in the next couple of years or so.
So Brian, can you talk more about the setting expectation part? People think they buy an expensive robot, it's going to do all these things for you, but you don't want the consumers to be disappointed. So the consumers need to know what they can really expect from that new product. So how do we go about setting that expectation?
Well, I just said I thought it was a challenge. I didn't know. I didn't say how to solve it. So I think the key thing is not to oversell it. So there's this famous period in artificial intelligence research in the 90s called the artificial intelligence winter. And it's when AI was promised promised as this new technology that was suddenly going to let computers do anything and everything, and then it failed to deliver on that promise, and that actually led to dramatically decreased funding from governments and other sources in AI research, and it took quite a long time for that to recover. And I think we would do well to look at that example and not overpromise what these robots are going to do. And I think we have to actually be really careful in publicizing what robots are doing. So, you know, I showed you a video earlier of a robot folding a towel. I should have told you, if you were to put this robot in your house, it probably won't fold your towels. And that, you know, because it's not quite the right environment, you have a different kind of towel, and the table's not at the right height, whatever the issues are, the videos that you see of robots doing demos are going to be highly misleading if you try to, if you're going to assume that that robot will do the same thing in my environment with all of my stuff in my house. And so I think we have to be really brutally honest in the way that we're publicizing what we're doing with robots in the lab, and be careful to explain all the circumstances surrounding how the demo happens. And then, I don't know, I mean, it runs a little bit contrary to the idea of the general purpose robot, but I think that we would also do well to sort of narrow the scope somewhat, at least at first, of what we're saying the robot is intended to do. If you sell the robot, if you market it as a general purpose robot, it can do, you know, it can be your general helper in your house. People, I think, are likely to be disappointed if you can find a really useful subset of being a helper that you can do really, really well, then I think it would make sense, just from a expectation setting point of view, to focus on that. But that's me being an amateur marketing guy. I'm not sure I know what I'm talking about there.
James, so what should we expect from the network? Is it always going to be on for my robot?
So, I mean, I think, you know, for safety critical functions, you know, there always has to be an embedded system on board that's keeping the robot safe. And if it loses connectivity to the network, it will be less useful, maybe less capable, but it will still be safe. It's kind of like, you know, your desktop computer at home. If your power goes out and you lose connectivity, but you have a battery backup, you can still use your computer, but it certainly is not as useful if you can't connect to the network. And so I think the same thing will be true of a cloud robot. As far as setting expectations, it's funny because, you know, I fully expected by the time I was 40 years old that, you know, we would have built C3PO. Because I grew up with Hollywood and these visions of very, very smart, intelligent, walking humanoids and robots. And I think we're still fighting against that. I think Hollywood sometimes is our enemy here, because I remember going to many National Science Foundation, you know, and trying to get proposals when I was at Carnegie Mellon for funding, and the most common examples that people knew about for humanoid robots were Terminator, or you know, like these kind of robot apocalypse types of movies. And then, of course, if you're really working on research, you realize that, you know, Terminator was the most robust robot ever conceived, and, you know, you couldn't kill it. But here, our robots are actually the complete opposite. You know, they're very fragile and very easy to trick, and you just unplug them if you're tired of them. It's not a big deal. So I think, you know, fighting against the visions of Hollywood and what the general population also expects of a robot is also important. But you know, so being realistic, but also I think limiting the domain. You know, sometimes I think with AI too, that was sort of the problem with this AI winter, was that the grand scheme was that we would achieve human level intelligence within 10 years. But instead, what we did is we excelled at certain small, narrow domains, like playing chess or playing checkers now, or, you know, whatever, like these smaller domains. And can we carve out those applications that are niche, like the Roomba, you know, maybe solve vacuuming for most of us. You know, let's find these nice, you know, kind of useful task domains where a robot can succeed and be reliable and cost effective and really nail this.
So we'll open up for questions, but just before we do that, I talked a little about the strengths and challenges that are faced. I didn't use the word weakness. Challenges that each country faces. But is there anything that you feel that the strength of the United States and Japan moving forward in robotics?
Yes. So I see that the big strength in the U.S. is that the robotics market is very fast and growing, especially Roomba, and also I see those the statesman's delivery robots such as like tug robots and so on. I can see tug robots just running at the El Camino Hospital too. So anyway, so that's one big strength as opposed to Japan. That the Japanese government is very conservative. So even though our products, Toyota's products, even though we're trying to launch our business, but Japanese government says no, that we cannot have more field trials at the outside the hospitals or the different public domains like airport and library, museums, and so on. But in the States, you can just run those robots you see at the very quick manner. So I think that the U.S. has a very fast production, maybe a fast business marketing. But in Japan, even though I see that a lot of companies, researchers are working on, universities are working on this service robot or humanoid type of robot research and development, but I see that I feel that the Japanese market, maybe or Japanese government has to act quickly based on this research trend, and also the other countries manufacture and non-manufacture, but the production of the business marketing trend. Otherwise, the Japanese government, our Japanese marketing, robotics marketing may be losing by other countries also.
I see. So there's a receptive market, but there's the government is in the way. Okay.
So I guess I can try to agree with that and further the point by saying that I think the Japanese market is, as far as I can tell, incredibly receptive to new technology and robots in particular. So I think that should be one of the first places that robots are deployed on a widespread basis in the homes. That would just seem to be very natural. I didn't know about the Japanese government's kind of track record on that kind of thing, but I can say that from my experience with the U.S. government, they tend to be very good at investing in high-profile competitions, such as the Robotics Challenge. And that's just one example. There are many, many challenges. There's someone who works in the White House Office of Science and Technology Policy. Her full-time job is spearheading challenges that are funded by various parts of the U.S. government. And with these challenges, the government's goal is to lay the infrastructure that will change the world in those areas. And so I think that, for what we're doing with the Robotics Challenge, our program manager told us that he sees this simulation as the lasting legacy of the program. That's the thing that's going to catalyze the industry, is having the access to this tool that's being built. And I think that shows a lot of foresight in terms of directing resources. And that's surely not unique to the U.S., but I think at least right now, an area that we're working in the U.S. is doing a pretty good job.
I'll just say that having lived both in Japan and the U.S. and being involved in the robotics research communities, Japan has a lot going for it because it has the use cases of healthcare and disaster recovery, and of course all the consumer electronics and the manufacturing, office, domestic use, and so there's a great opportunity there, and also just the track record of manufacturing very high quality, reliable electronics and machines, including cars. It seems natural that car companies that have a history of and knowledge of how to actually build a machine and then really test it under all these conditions, snow, rain, ice, and make sure that it really works and is robust, could use that knowledge and leverage that skill to deploy a robot. And so I think Japan is very well positioned, barring some bureaucratic or legal hurdles, which I know are very challenging, and also challenging in the U.S. as well. But I think I see a bright future if, as a society, we can also, allow innovation to flourish, provide a an atmosphere and an economic environment where people can invest in new technologies and deploy them and sell them and increase the pace at which the innovation happens and not get bogged down. I think we have to be optimistic and 一緒に頑張りましょう.
Okay, so does anyone have any questions? Please come up to the microphone.
Please come up to this microphone and you might want to line up.
Hi, Ian Danforth of Numenta. I just want to offer a solution to the expectation setting problem that you guys have illustrated or enunciated. Don't call them robots. And I'm absolutely serious about this. One of the greatest things